Chapter 5. Evolution and the Objective Mind. On the following page will be found a Table 1, the data for which I have taken from Haeckel's Evolution of Man. The first column comprises an estimate of the Neptunian fossiliferous strata of the Earth, with reference to their relative sectional. The second column embraces a systematic survey of the paleontological periods, or greater divisions in the history of the organic Earth. The third column is a statement of the percentages assigned to the relative durations of the 5 main divisions or epochs, as shown in the other 2 columns. Thus the reader has before him, in one view, the salient facts in the history of organic evolution, and the geological data from which the time estimates have been made. That they are both substantially correct is not seriously disputed by competent authority, although no pretense can be made of absolute correctness. It is entirely probable that the grand divisions outlined may lap over each other to a limited extent, but it is impossible that they should do so to such a degree as to invalidate any conclusions that have been, or are likely to be, drawn from them. Thus, it may be that the line between the primordial and the primary epochs does not sharply define the boundary between the invertebrate ancestors of man and those of his more pretentious relatives who can boast of the regulation backbone. Nor is it quite certain whether man did not make his first appearance sometime during the Cenozoic epoch. But a few thousand years more or less on either side of the line dividing any 2 epochs does not count for much when we consider the eons that must have elapsed since the first appearance of organic life upon this planet. The relative duration of the epochs is sufficiently apparent in the thickness of the various Neptunian strata to justify the few conclusions that pertain to the subject under consideration. There are 2 primary lessons taught by facts stated in the table that are as obvious as they are important. The first is that a brain is not necessary either to the sustentation of life or the manifestation of intelligence. Indeed, it may be said that more than 1/2 of all the millions of years that have elapsed since organic life appeared upon the Earth have been consumed in demonstrating that fact. The second lesson is that a brain is necessary to the rapid development of life and intelligence. The table of time percentages shows that progress is exactly proportioned to brain development. Thus, the primordial epoch, or age of brainless animals, occupied more than 1/2 of the whole time. That is to say, in the absence of a brain it required 53.6% of the time that has elapsed since the appearance of the Monera to develop the animal kingdom up to the lowest of the vertebrata. The next epoch was the age of fishes, and they being endowed with brains, the rate of development was correspondingly increased. But a little over 32% of the time was consumed in developing from them the amphibia and the reptiles. It was a long drawn-out epoch compared with those that followed, but it was a decided improvement over the one that preceded it. The brains of fishes are not very highly developed or specialized, but the table of percentages shows that they were a decided improvement upon no brains at all. The best evidence of that is that they were capable of development, and this is shown by the fact that the more highly endowed fishes sought fresh fields and pastures new by making occasional incursions upon dry land. From these were developed the amphibia and the whole reptilian race. The age of reptiles, as shown by the table, consumed but a little over 11% of the time in developing the mammalia. The mammalian age, in turn, decreased the percentage in a still greater proportion, consuming but a little over 2% of the whole time in developing up to man. Lastly, the age of man embraces but 1/2% of the whole time since organic life appeared upon the Earth, and this includes the glacial period. In the post-glacial period, it is obvious that if we should segregate the period of culture, or historic period, from that of prehistoric man, we should find that the percentage of duration of the historic period was but an infinitesimal part of 1% of the whole. We are now, in some measure, prepared to appreciate the part which the brain has played in the development of organic and intellectual life on this planet, for we have seen that, since it became a part of the equipment of organic life, it has accelerated the progress of evolutionary development in a geometrical ratio. It has, moreover, changed the original significance of the law of survival of the fittest. Thus, before a brain was evolved, fitness to survive was wholly a matter of physical strength or development. After the development of the brain, sagacity became the most potential factor in the problem of survival, and from the time when the most highly developed fishes began to seek safety in a new environment. By crawling out of their native element and taking refuge upon the dry land amphibia, until man appeared upon the earth, sagacity has been a factor of constantly increasing potency in the survival of the fittest. Man is so far advanced in the scale of being that he is comparatively independent of environment, or rather he is able to create his own environment, and physical strength is the least in importance of the factors in the problem of survival. These, however, are trite sayings and are matters of common observation. What concerns us most, for the purposes of this argument, is the process by which this development was brought about, and the conclusions derivable from a study of that process. In pursuing this study, I hope to find a solution of several problems that have perplexed the scientific mind, among which are the following. First, what is the real office and function of the brain in organic life? Secondly, when do animals begin to exercise the powers of reason? Thirdly, what is the potential factor in the development of secondary instincts? In discussing these questions, I shall first postulate certain things regarding the functions of the brain, leaving some of their verifying facts to be developed in the discussion of the remaining questions, and referring the reader back to some of the preceding chapters for other proofs of my postulates. I assume, then, that the brain is simply a physical organ, possessing but one distinctive power or function, namely, the faculty of inductive reasoning. It was evolved in response to the necessities of a physical environment, and the specific office of the intellectual faculty, or mind, of which it is the organ, is that of a guide to its possessor through the manifold mazes of that environment. This intelligence, which has been denominated the objective mind, apparently does not constitute an integral part of the primary intelligence or subjective mind, although it often acts in perfect synchronism with it. As I have already pointed out, the subjective mind, under and by virtue of the law of suggestion, is incapable of independently carrying on the process of induction. It has, however, the faculty of deduction in potential perfection. It must, therefore, take its premises from an extraneous source. The reason for this apparent limitation of mental power will more fully appear as we proceed. In the meantime, it must suffice to say that the subjective mind does not appear to have originated on this earthly plane, nor does it appear that this plane of existence is its final goal. Its first manifestation on the earthly plane revealed a far higher power than that of induction, and the world has named it instinct. Its higher manifestations are called intuition. As I have already pointed out, they are identical, differing only in degree. It is the power of immediate perception of laws or general principles, and it is antecedent to, and independent of, reason or experience or instruction. Induction is but another method of ascertaining general laws or principles. This it accomplishes by the slow and laborious process of gathering facts of observation or experience. It possesses the faculty of discrimination between what is real and what is apparent, and of estimating the value and pertinency of all the facts of its environment. Hence its adaptation to an imperfect environment, such as sentient creatures are compelled to confront in this world, an environment that is filled with snares and pitfalls, physical and moral, enemies to life and foes to progress, an environment of error, falsehood, and uncertainty, in short, a world that is in a formative state, just emerging from primitive conditions, physical, mental, and moral. Obviously, the one mental faculty adapted to cope with the exigencies of such an environment is that of inductive reason, the faculty of discrimination. The faculty that enables its possessor to arrive at fundamental truth by a process of systematic analysis of facts and appearances, of proving all things, and holding fast only to that which is good. The subjective mind does not possess that faculty for the reasons that, as I have before remarked, it apparently had its origin in another and a higher plane of existence, and 2, it is apparently destined, ultimately, to return to its native realm. I shall assume, provisionally, this to be the correct hypothesis, reserving the proofs for their proper places in subsequent chapters of this book. In the meantime, it must also be assumed, subject to subsequent verification, that the environment of the ultimate home of the human soul is perfect. That is to say, it is a realm of truth, a realm where no falsehood or false appearances beset the minds of its inhabitants. It is obvious, therefore, that the faculty of induction would be superfluous in a realm where nothing but truth is in evidence. Nevertheless, a faculty adapted to such conditions is required, and that faculty we find existent in the subjective mind of man, namely, that of intuition, the faculty of evolution, and the objective mind. 115 Immediate apprehension of fundamental truth, antecedent to, and independent of, reason, experience, or instruction. Now, it is axiomatic that nature never creates an unnecessary or a superfluous mental faculty. It follows that the faculty of intuition, since it is limited and circumscribed in this world by the law of suggestion, must reach the full fruition of its powers in some higher plane of existence. For a full discussion of this particular branch of the subject, see A Scientific Demonstration of the Future Life. It is incidentally mentioned here to complete the present argument. It is also axiomatic that nature never fails to create or evolve such mental facilities as are necessary to adapt sentient creatures to their environment. The history of organic and mental evolution amply verifies this proposition. Thus, the primary intelligence amply sufficed for the first stages of development, that is, during practically the whole of the primordial epoch. This, as we have seen, was the age of skull-less animals and seaweed forests. During the whole of this epoch, the inhabitants of our planet consisted exclusively of aquatic forms. At least, says Haeckel, no remains of terrestrial animals or plants dating from this period have as yet been found. A few remains of land-dwelling organisms, which are sometimes referred to the Silurian period, are Devonian. Vegetable life capable of sustaining animal existence had not yet appeared upon the dry land. There was necessarily but little variation in the aquatic environment, and there was nothing, therefore, to facilitate or incite a rapid development of either organic or mental life. As a consequence, the primary instincts being alone developed, the process was slow. Nevertheless, there was progress made, and at the close of the primordial epoch the lowest of the vertebrate ancestors of man appeared and a brain began to be evolved. It was then that animals began to reason. It was then that the faculty of induction became a potential. It was a long time before it was so developed as to leave a record of its existence, but the time came at last, and the first phenomenal manifestation of that power that left an impress visible to science was when the most highly endowed fishes began to seek release from their native environment by making incursions upon dry land, and thus gave rise to the amphibian class. It was then that secondary instincts began to be developed. That is to say, it was then that intelligent acts began to be performed which eventually were converted into instincts. Darwin. Before entering upon the discussion of that branch of the subject, however, let us briefly examine the essential character of the process of induction as it was and is manifested in the lower animals. Inductive reasoning, as everyone knows, when considered as a distinctive faculty or power of the human mind, consists in collecting, classifying, and analyzing the facts of observation and experience, for the purpose of ascertaining the general law or principle underlying the series of facts under consideration. It is the faculty of discrimination. It is the power of adaptation to environment, and this is true whether it is manifested in man or in the lower animals. And it may be set down as axiomatic that, other things being equal, the power of adaptation to environment is exactly proportioned to the development of the faculty of induction. An animal without a brain will perish in a changed environment. Man alone possesses the capacity to adapt himself to the extremes of environmental conditions, for he alone has the power to modify existing conditions or to create new ones for himself. Between these two extremes there exist 1,000 grades of adaptive capacity, but, as before remarked, the grade is determined by the development of the faculty of induction. The simplest way to explain what I mean by induction in the lower animals is to contrast the functions of the objective and subjective minds as they are manifested in all grades of mental capacity. I have already shown that the subjective mind of man is constantly amenable to control by suggestion. Hypnotists described the effect upon a hypnotized subject as monotheism. That is to say, the subject is dominated by one idea to the exclusion of all other ideas that are antagonistic to the one embraced in the suggestion that has been made to him. That idea is accepted by his subjective mind as the fundamental law pertaining to the subject matter of the suggestion, and he proceeds to reason deductively from that supposed fundamental to all the conclusions legitimately derivable therefrom. All other facts, especially those which antagonize the dominant idea or suggestion, are ignored. This is true whether the suggestion is true or false. It is obvious that, if the suggestion is false, the deductions will lead to the grossest error, although they may be perfectly logical in themselves. It is also obvious that, when the suggestion is true, the prodigious power of correct deduction, which is characteristic of the subjective mind, enables it to grasp and assimilate all that there is of truth deducible from the suggestion. Hence it is that, in an environment of truth, the subjective mind is never led astray, for its power of intuitive perception of the laws of its being and environment always ensures truthful suggestions. And its power of potentially inerrant deduction ensures correct conclusions. But the physical world does not afford such an environment, and false suggestions in every conceivable form continually beset every sentient creature. Hence the necessity of investing the animal kingdom with a faculty adapted to such an environment. Hence the evolution of the brain, with its capacity for induction, its faculty or power of discrimination, its ability to consider more than one fact or appearance at a time and to estimate their respective weights and values. And this is inductive reasoning, whether it is manifested in the scientist, who collects a vast congeries of facts and classifies and weighs them with the intelligence born of culture and experience, or in the animal which is only capable of comprehending two facts at a time and weighing their respective values. This, then, is the primary distinctive difference between the two minds. The subjective mind considers but one fact or suggestion at a time. It accepts that fact, or that apparent fact, or suggestion of fact, as true, and it acts accordingly. This is what is known to science as the law of suggestion. On the other hand, the objective mind is capable of considering two or more facts, or suggestions of fact, and of exercising a discriminating judgment between them. It is the difference between instinct or intuition and induction. In an environment of truth, the first is inerrant. In an environment of uncertainty, the second becomes necessary. The history of organic evolution shows that whatever was found to be necessary to the conservation of animal life was eventually evolved in response to that necessity. Accordingly, when a supplemental faculty of mind became a necessity, a new physical organ was evolved, the function of which supplied the deficiency and gave to animal life a fresh impulse in the direction of progressive development. The conclusion seems obvious and irresistible that it was when the brain was evolved that animals began to reason, that is, to reason by the process of induction, and that it was due to the development of that faculty, and in exact proportion to that development, that the constantly accelerated ratio of evolutionary progress was due.